Hey guys, and in continuation with the previous session, we are going to see about the volumetric strain. So volumetric strain means whenever an object or whenever the circular object or circular rod which is subjected to the either by axial pull or otherwise axial push. Okay, so because of that it may there is a changes will be taken place. Okay, that changes which is what do you call that change in volume, and it is what do you call that original volume. The change in volume and the original volume, it can be represent, it is a volumetric strain, which means the object subjected to volume changes. Okay, that volume changes is what you call that volumetric strain. Okay, so this details is nothing but volumetric strain can be equal to del of V, which means change in volume with respect to the original volume. Okay, and here we going to follow on this entire subject, which is mainly based upon the Hooke's law. Okay, if you're going to design any material or whenever the load applied over some material, okay, it can able to withstand the load, or if it is within the elastic limit. Elastic limit means we know that there is whenever the material subjected to the load, okay, with respect to the stress load act over the body, the first point is called yield. Following that there is an proportional limit, along with that elastic limit is there. Within elastic limit means the material cannot getting tear the part after this load. It is a maximum point of withstanding load. It is a maximum level of resisting force. That is what you call that the material is loaded within elastic limit. Okay, here stress is equal to Young's modulus into strain, where E refers it is the Young's modulus, or also called it as modulus of elasticity. Okay, and when we going to take a factor of safety is nothing but it is the ratio of ultimate tensile stress to the permissible stress. Okay, it is the ratio of ultimate tensile stress to the permissible stress. Okay, so this is the basic thing. When we enter into this subject, we should know whether the load or act over the material it is within elastic limit or beyond the elastic limit. Okay, that is what you need to discuss in detail regarding this factor of safety. Factor of safety is nothing but it is equal to ultimate tensile stress divided by permissible stress. Okay, that is what you call that factor of safety. Here when we going to study about the deformation of the body, it is due to the force acting over the system. Okay, for example, if you are going to study the deformation of the body with respect to the force, we need to understand the stress is equal to load by area and strain is equal to change in length by original length. From the Hooke's law, we need to take a calculation. Young's modulus E is equal to stress divided by strain, and we know that stress is equal to load by area, and with respect to that there is a strain has been act over it. That strain can be defined as one is called Young's modulus, along with that longitudinal strain will be there. Okay, here E refers is stress, and wherever the small e refers it is a strain. Stress means it is a load by area. Strain means it is a change in length divided by original length. Okay, so when we are equating this equation, we know that strain is equal to del of L divided by L. Okay, so instead of the strain I am going to write load divided by area into Young's modulus, and del of L is equal to equating these two different equations, the del of L is equal to PL by AE. Okay, so this is the case. We need to understand there is a change in length with respect to the load and with respect to the area it has been calculated, and we will continue on next session.